today's lesson is all on division of polynomials. We're going to use two methods, the reverse tabular method and the long division method. Synthetic division will be in a different lesson. So first, a little vocabulary. When we multiply two items, they're referred to as factors. As you see here, quantity 2x plus 5 times quantity x squared plus 5x plus 1. Those are each factors. And a factor times a factor equals what we call a product. Of course, when we're multiplying, we get a product. When we're dividing, the vocabulary is very different. On the top, we have a dividend, and on the bottom, a divisor. And when we divide, we get what is called the quotient. So I can take the same polynomials from the factor equals product, and I put my product on the top. So you see the quantity 2x cubed plus 15x squared plus 27x plus 5 is our dividend, divided by this factor equals the other factor. And likewise, that same product on the top divided by the other factor, so this one's under there, gives you the other factor. So that's what I want you to notice here, is that each of the factors divide evenly into the polynomial and they produce the other factors. So each of the divisors produce the other factor from the original. Something like that. That's really what I wanted you to see. And we can also take and see that our quotient, or our answer to division, our quotient times our divisor, again, gives us the dividend, and that was also the product from up above. So we can use these words sort of interchangeably. We don't want it to get too confusing, but that's some of the vocabulary. So then what else we see? We have polynomials f of x and d of x. When we divide them, we get a quotient, and sometimes we get a remainder. So the remainder is either going to be 0, or the remainder, we're sure, will have a degree smaller than the degree of the divisor. So we know degree of remainder is less than degree of divisor. That's just what that is saying, sort of in simpler terms. When something divides evenly into another polynomial, we know that the remainder is 0. So, for example, let's take a real easy one, x squared plus 6x plus 5. If I divide that polynomial by x plus 1, so let's factor that numerator. And you can see these factors will reduce out. So these factors will each actually divide evenly. And we know that because the remainder is 0, or there is no remainder. And these themes will be coming up throughout the lesson. And likewise, what it shows up there is I could take that same polynomial as my dividend and divide by the other factor, which indeed became the quotient over here. And again, I think you can see that when I'm dividing by the quantity of x plus 5, then those will reduce, and the solution is x plus 1. Here, the solution was x plus 5, so you get the other factor. That's what I was trying to show you up top. Okay, so let's take a look at what we're going to call reverse tabular division. And it's using the table just like we did in multiplication. So we are going to use it to find 2x cubed plus 15x squared plus 27x plus 5, this, divided by 2x plus 5. So if I were multiplying, that would have been my product. Remember, our products came out down here. So I'm going to write this. You want to write this way over to the left below the box. Just like that. And this time we're going to put our divisor along the left. Okay? Now we're going to use all the knowledge that we have from tabular multiplication to figure out our quotient up here. So we're looking for this up here. So first thing we know is that 2x cubed would have come from this box. So I'm going to put it in there. Now we have to work backwards. If we know that 2x cubed is in this box, then we know it came from 2x times whatever is here. So this must be x squared. Now that you have the top of this column, you can fill in the whole column by multiplying. So x squared times 5 is 5x squared. Then we know that 15x squared came from this box and this box. So I know this had to be 10x squared. Work backwards to get this next term. 2x times what gave us 10x squared? And that would be 5x, and it's positive. Now that the top of the column is done, we can complete the column. 27x came from 25x and this box. So this must be 2x, which, knowing that 2x times something gave us 2x, that something is 1. Now that we have the column, we can finish the column, and lo and behold, it goes in evenly. So the quotient for this division is x squared plus 5x plus 1. Now they'd like us to verify that it's correct. So from earlier, we know one way we could verify would be to multiply those two together. Our quotient times our divisor should give us our dividend. So let me just do some distributive property. Do it with me. Or you could pause the video right now and try it yourself. X squared times 2x. X squared times 5. 5x times 2x. 5x times 5. 1 times 2x. And 1 times 5. Combining like terms, I get 2x cubed plus 15x squared plus 27x plus 5. And we are good. We have verified. Next question says, why does the degree of the quotient make sense? So the degree of our quotient is 2. Let's consider the degree of our dividend. It was 3. And the degree of our divisor. The degree of our divisor was was 1. So here was the 3 in the dividend, and the divisor was 1. And we know that what we just checked was the divisor times the quotient. So these two should add up to the dividend. So 2 plus 1 should be 3, or 3 minus 1 should be 2. So you can look at it as this 3 take away this 1 should equal this 2. Okay? Or you could look at it as this 2 with this 1 should give me 3. So it does make sense. There is no remainder, so what's another name for the divisor? So the polynomial on the bottom is a factor. If it divides evenly, it is a factor. Okay, so we tried the tabular method. Now we're going to divide using long division. So the long division algorithm for polynomials is very much like the long division algorithm for numbers. We're going to take 13 and see how many times it goes into 15. That's once. And then we multiply and subtract and bring down. And then we start over. 13 goes into 27 twice. We multiply, subtract, and bring down. And we start over. 13 goes into 13 once. Multiply, subtract, and we're done. And look, we got a factor. We got a factor because we have no remainder. So we're going to do the same thing here. But we're going to use our leading term. So here we have an x. So my first question is, how many times does it go into x cubed? And that's the same as asking this. So it's x squared. Once we get our value up there, or our expression, we multiply. So I've got x cubed plus 3x squared. And then remember, we subtract. So I'm going to show that I'm subtracting by changing all my signs in the polynomial. And I circle them as well, so that I remember I changed them. Because now I can just add down. Okay, whoops. I'm going to add down, and I'm going to bring down one term. That's all I need. Get a little rambunctious. And then we start over. X goes into 2x squared. 2x times. Multiply, multiply. Change our signs for subtraction. And we've got x right here. And bring down. Bring down the 3. We start over. X goes into x. You know what that one is. That's 1. That's x plus 3. And once I change the signs, I get 0. And 0 means, I want to do a smiley face there. 0 means it was a perfect factor. No remainder. So this quotient is x squared plus 2x plus 1. Now I really just want to practice both of these methods with you. This final question on the page says, is x plus 3 a factor of this polynomial? Yes. And our reason for that? Because the remainder was 0. You could say because it divides evenly. So let's practice now both algorithms. And the directions say use the tabular method and long division to do each of these. And clearly they should come out the same. I will do these first two, and then long division with this one. So our divisor on the outside. Okay, here we go. X goes into x squared, x times. Multiply, multiply. Subtract, subtract. Bring down and start over. X goes into 7x 7 times. Multiply, multiply. Subtract. And we have a perfect division. The quotient is x plus 7. Let's try the same one with the tabular method. So tabular method. Remember, we're going to take our dividend and put it in the bottom left of your workspace. You're going to put your divisor along the left-hand side of the box. I don't worry about how many columns I will have. I simply figure it out as I'm going along. So we know that x squared came from here. Okay. So now we know that this column has an x, because x times x gives us x squared. Once we have this value up here, let me put a highlighted section up here, what we're looking for. Okay. Once we know that value up there, we can fill in the whole column. X times 3 is 3x. 10x comes from 3x plus this box. So I know this is 7x. And then I can fill in the plus 7 up here because 7 times x is what gives me 7x. I now have my column ready to go. I got a 21 with 7 times 3, and there's my 21. So that was it for the box. And just clean that up a little bit. And our quotient, we already knew, is x plus 7. There it is again. Let's try it with this larger problem. We'll do long division. Well, let's switch it up. Let's do tabular division first. I have x to the 5th plus 2x to the 4th. And then notice it skips to x squared. So remember, we ran into this. We really want to put that 0 term in there. So 0x cubed minus 7x squared minus 19x plus 15. Okay, pull this down a little bit. And my x squared and positive 2x and positive 5 go along the side. And we are using the tabular method to figure out this quotient. From this square. I'm going to put my x to the 5th in there. And this is the next value. You can start right away. X squared times what gives you x to the 5th. And that is x to the 3rd. Now I can complete the column using tabular multiplication. Then I grab my next term, and I know that it came from 2x to the 4th, and this box. So this box must be 0, because it's already 2x to the 4th. So if that's 0, I know I have 0 here because only 0 times x squared gives me 0. So my whole column is 0. Cool. Then 0x cubed comes from this box and this box and this next box. So if it's 0x cubed and I have a 5 and a 0, I need a negative 5x cubed to give me 0. 5x cubed and negative 5x cubed. Now that I know I have negative 5x cubed, x squared times what gave me that? Negative 5x. I've got my column values, so I can fill in the whole column. Negative 10x squared, negative 25x, and we're good to go on to the next term. Negative 7x squared. I moved these guys over a little bit. Negative 7x squared comes from this, and the next value. So I have a 0. I have a negative 10. To get negative 7, I need positive 3. Positive 3 in this spot times x squared here means I have a 3 in the column header because 3 times x squared would give me 3x squared. Now finish the column. What's 3 times 2x? What's 3 times 5? Next term, negative 19x comes from negative 25 and positive 6. It does. And positive 15 comes from 15. So we are done. Our quotient, whoops, I didn't want to do that. Our quotient is, I was moving the arrow, thank you very much. Our quotient is x cubed minus 5x plus 3. Okay, let's see, we're up to 22 minutes. I'll let you finish this with long division. Don't forget that 0 term. And this time, since we're dividing by a trinomial, when you do the bring down part, you want to bring down 2 terms. So we'll leave room for that. And this says, what conclusion can you make about the divisors? So our divisors are also factors. They are factors because there are no remainders. And does the degree of the quotients above, do the degrees of the quotients make sense? So think about either the subtraction of the degree of the divisor minus, the degree of the dividend minus degree of divisor, your degree of dividend minus degree of divisor should equal degree of quotient. So you can just kind of check those, make sure they work. On this last page, let's see if there's anything crazy or new here. Use long division to determine the quotient. All right. Cube squared x10, that should be no problem. And number 4 just says find the quotient. So you could use long division, or if you'd like, you could use tabular, but please notice you're missing 0x to the 4th and 0x cubed squared 0x. So you want to squeeze all of those between these 2 terms. All right. And then the very last question, just to set you up here. As you're performing the indicated operation, then to simplify by combining like terms. So you can multiply these out, and then you have to divide these out, because multiplication and division comes before subtraction. So be real careful, get your product here and your quotient here, and then make sure that you put parentheses around that quotient. Okay, I'm going to leave you with that, and I will see most of you on Tuesday. Bye-bye.